What is matter made of? Let us do an experiment to figure out. Let's add some sugar to water. Observe that the level of water increased above 100 ml. Now stir to dissolve sugar. You will see that once dissolved, the level of water comes back to the original level of 100 ml. Why is the level of water the same even after adding sugar? Where did the sugar go? This can be explained if we assume water and sugar are made of small particles. Water is made of water particles. When you add sugar, its particles will settle down separately. So, there will be increase in the level of water. But once you stir, the sugar particles settle in between the gaps of water particles. Since sugar particles go into the gaps, no extra space is required. So, water level comes back to the original 100 ml. How small are the particles and how many are there? Take some water and add few crystals of potassium permanganate. The water will become pink. Now take a little portion of this pink water and add it to another beaker of clean water. It will also become pink. It will be little light than the first beaker, but it will still be pink nonetheless. What we have done in this process is we have picked very few crystals of dissolved potassium permanganate and dropped it to the second beaker. But since the second beaker also became pink, we can infer that there are still a lot of particles in the second beaker. Let's continue the process to the third beaker and to the fourth beaker. And we still see the fourth beaker is still pink, which says that there are still a lot of particles of potassium permanganate present in it. This shows that even a small crystal of potassium permanganate has a lot of very tiny particles. Solid has a definite shape. Liquid does not have a definite shape, but when you put it in a vessel, it takes the shape of the vessel. But it takes only a definite volume of the vessel. It does not occupy the whole vessel. Gas doesn't have a shape. It also takes the shape of the container. It also does not have a definite volume. If you put it in a container, it takes the whole space in the container. To summarize, solid has definite shape and volume. Liquid has no definite shape but has definite volume. Gas doesn't have definite shape nor has a definite volume. Characteristics of particles of solids, liquids and gases. The particles of solid stick together. The particles of liquid are a little loose when compared to the particles of a solid. The particles of a gas are loosely packed. None of these particles are static, they keep moving. In solids, the particles vibrate. Even if you take a solid like iron rod, you may not feel it, but all its particles will be vibrating all the time. In case of liquids, the particles move on one another. In case of gases, particles move really fast around the whole container. Kinetic energy is the energy associated with motion. Since particles of gas move faster, they have higher kinetic energy. Particles of a liquid which move slower have little less kinetic energy, and particles of a solid which just vibrate have least kinetic energy. When you heat a solid, you are supplying energy. This helps the particles of a solid to gain kinetic energy and move faster. At a point, when you heat enough, they gain enough energy to become a liquid. The temperature at which solid turns to a liquid is called melting point. Now, if we have a liquid where particles don't just vibrate, move on one another. If you continue to heat, the temperature of a liquid also increases and at a point it turns to a gas. The temperature at which liquid turns to a gas is called melting point. If you reverse the process and cool instead of heat, gas particles move slower and become liquid at a temperature same as boiling point. This process is called condensation. If you further cool the liquid, we'll get a solid and the conversion happens at a temperature same as freezing point. If you further cool the liquid, we'll get a solid and the conversion happens at the temperature same as melting point. We can also call it freezing point. This process is called freezing. In some cases, solid directly converts into a gas on heating. This process is called sublimation.
Can we change the state of the matter by increasing or decreasing pressure? Yes, we can. Remember liquefied petroleum gas or LPG. There, a gas is liquefied. How? On applying pressure on a gas, it gets converted to liquid. This is what is happening with LPG. If you apply more pressure, it will get converted to solid. So applying pressure, gas will get converted to liquid, and if we apply more pressure, the liquid will turn into solid. Can water change into vapor only at 100 degrees Celsius? What happens if you spill a little of water on the floor and see it after a while? It has vanished. What happened to it? It got converted to vapor. But we did not heat it. How did it attain 100 degrees Celsius? It did not. Water particles just need to get some energy to vaporize. At room temperature, all the water particles do not have this energy. But particles on the surface can gain this energy from atmosphere and vaporize in evaporation. While on boiling, all the particles in the liquid vaporize. Evaporation can happen at any temperature, but boiling happens only at 100 degrees Celsius. Factors affecting evaporation. First one is temperature. Higher the temperature, faster is the evaporation. Second one would be the surface area. More surface area helps evaporation. Water spread on plate evaporates faster than water on a glass. Wind. More the wind, higher the evaporation. This is why clothes dry faster on a windy day. Humidity. Humidity is the amount of water present in the atmosphere. Evaporation happens slowly if the water vapor is more in the atmosphere. So, more the humidity, less is the evaporation. Why do we sweat? We sweat in summer. Sweating evaporates by taking energy from our body, thus cooling our body.